And the
Wait, start that over, would you?
What?
really?
Really?
Okay, so
I'll restart the time we're going.
So, all right. So the simplest circuit you can have is a voltage source and a resistor. And got some notes here. This guy's usually grounded. And then you hook up some load to this. Load. That's the simplest circuit you can build. And what Thevenin's theorem says is that you can simplify any circuit into this, a source voltage and a series resistance. So it's very useful, and let's just do an example really quick. We'll do it over here. So if you've done electronics for a while, people are familiar with the voltage divider circuit. Where the output voltage is the input voltage times this ratio of the lower resistor divided by the sum of the resistors. So that's a common circuit that people use a lot. We can simplify this guy into just this. And how you do that is first you calculate the voltage here, which we know by this. So let me make this easier. Let's just say this is a 9-volt battery. This is a 300 ohm resistor, 600 ohm resistor. And we plug all this into this guy, we get V out equal to 6. So, this is VT and RT. So we know our VT, our VT. The Thevenin's theorem says our VT is the voltage out here, and our RT is the resistance, what they call it the source resistance, where you look back into this. What this means is you take your voltage sources, and you shunt them to ground, and you calculate the equivalent resistance here. So the equivalent resistance here is just a 300 ohm in parallel with a 600, and 300 parallel 600 is just going to be a 200. So the equivalent, the thing inside this purple box is completely equivalent to 6 with 200. So that's one thing to use Thevenin's theorem for. Because of this, one useful thing that I use it for is to predict, to know more about the output of like an IC pin. Like you don't know what's inside, but you can simplify it to something like this, and then you know how this series resistance and this source voltage is going to affect what you need to do with it. So if I'm probably running out of, I have a minute left, but let me just try my best here. I wasn't planning on getting this far, but so if a lot of people use the inverting op-amp configuration, where V out is equal to minus the ratio of the feedback resistor over this resistor. So if you don't know what you're dealing with, like we had a 200 ohm series resistor, let's say that was the output of an IC pin. If we just put like a 1K and a 1K, we still have and then we hooked it up to the output of that IC pin. We have 1K and 1K, we got it wrong because we have the 200 in here. So we would be better, now that we know that there's a 200 there, you put 800 in it.
Can I do a talk? Choose your last sentence. cheat.
Let's say I wanted to make, oh, I'm sorry, I did not put that there. I wanted to make V out equal minus Vn. I could pick 1K and 1K for this, and then I'll be like this. But if I picked that and didn't know what I had over here, and this was 1K and this was 1K, I don't really have this ratio right because I have to deal with this source resistance. So I would have had 1K over 1.2K, and I won't get the right gain. I won't get the right gain.
All right.
So it's good to know what your source is. I use this a lot on, I make video game cables for old video game systems, and every system I write this color bar test software and I put it on the oscilloscope, and I measure the output, and I measure it twice, unloaded, so I can get this guy, and then loaded, so I can calculate this guy, and so I know what's coming out of the system for each system, so I can put the right gain on my circuits.
Thank you very much.